I would recommend don't try to take notes because I'm going to be sending out the PowerPoint. Just listen and ask questions because this is going to be different than like what I did last week where I worked through problems, because this is focusing on the definitions, what they mean, and those kind of details, and everything's sort of in one place. So you have this as a good reference if you need to go back later on, so you don't have stuff like all over your notes. So that's sort of how this is going down, I guess you could say. So we're going to start with the word set because this shows up a lot. So any group of numbers is referred to as a set. And so an example would be like if I have even numbers. Let's just say I have the even numbers under 10. And we indicate that these are a set by using these are called braces. Or you'll hear curly brackets. So it's a special symbol, and they surround the things that are in a set. So this whole thing is a set. So this entire thing, not just the numbers inside it, but the symbols themselves include a set. So that's, what we use to indicate there's a set. So the mathematical definition says that it is a well-defined collection of elements. So when it says elements, those are the things that are in the set. So those are the numbers. Those are the elements of the set. And the phrase well-defined means that you know exactly what is inside there. So I defined this set as the even numbers less than 10, or I should say even whole numbers less than 10, because 0 could be considered an even number. That's not a whole number. So I didn't include that in the set. So you define it in such a way that you know specifically what numbers are inside there. That's what it means to be well defined. And if you take a set and then you pull out smaller groups of numbers from that, that is called a subset. So if I made a new set of just 4 and 6, then that is a subset. So that's this definition here. So then we've got opposites and negatives, and these are related. So that's why I have these on the same slide. So opposites. Two numbers are opposites if they are the same distance from 0, but on opposite sides of 0 from the number line. So like -2 and 2 are opposites. They're both 2 away from 0. There's a distance of 2 in either direction. So they're same distance from 0, but they're on opposite sides. So those are opposites. And we indicate that something is the opposite, or that we want to do the opposite, by using a negative sign in front. So that's what brings us to negative numbers. So negative numbers are the opposites of the positive or whole numbers there. So you basically have two sides of the number line, and they are opposites of each other. So that's why -2 has that negative sign to indicate that it is the opposite of 2. So same distance, just on the other side of the number line. So that brings us to what we call the set of real numbers. So we've just learned the definition of set, and now we're talking about real numbers. And these are the numbers that we work with all the time. Just if it's a number, it's a real number. And so it includes the positive and negative numbers. And then it also includes all decimals and fractions that we work with as well. So if you think of a number, it's a real number. And these are all numbers that we can put on a number line. So if you can graph it on a number line, it's a real number. And we have this special symbol that it's like a special R. When I write it by hand, we usually write it like that by hand, so we won't do the double R over the whole thing just for the first, the initial downstrokes. We'll do the double R, the double line basically. And so that's a shortcut symbol to mean real numbers. So there are other groupings of numbers, because remember, a set is a grouping of numbers. So if we want just the positive numbers and not include fractions or decimals, and we don't want to have zero, those are the natural numbers. And those, so that basically starts at 1, and then that symbol is an N with a double line. If we want to include 0, that's called the whole numbers. I don't know of a specific symbol for that. And we have the set of integers is where we throw in the negatives, but we don't have, none of these have fractions or decimals. And the integers have a Z with the middle being the double line. Then we've got what are rational numbers, and this is including all of these numbers we've talked about already, plus we start including fractions and decimals. And these have a symbol of Q for rational, because it comes from the word quotient. And that means basically that you are doing division or you've got a fraction. So we have a Q for the symbol, and then we just make a double line there. And so these are any number that you can write as a fraction. So most decimals can be written as fractions. Of course, any fraction falls into this. Any whole number can be written as a fraction. So integers are also rational numbers. And so we use this P over Q. So that brings us to what a fraction is. We call the top the numerator, the bottom the denominator. We're not allowed to have 0 in the denominator. So there are things that are called irrational numbers, which are basically the opposite of rational numbers. They can't be written as a fraction. And so there are certain decimals that fall into this category, like pi, because it goes on forever. E, another one that goes on forever. We've also got the square roots of numbers. Most square roots fall into this category, which reminds me that when I made this presentation, I forgot to put square roots in my presentation. So I'm gonna make a note of that and then add it before I email it. So I'll just add that slide in. So basically it's the opposite of a rational that can't be written as a fraction. And so decimals that can be written as fractions either end or have repeating decimals. So if there's no pattern, it's basically irrational. So that brings us to the set of numbers. And so we usually write this as like a Venn diagram thing. And numbers can fit into more than one category. So we start with the natural numbers, which is all the numbers, the counting numbers, basically 1, 2, 3, 4, and so on. And then when you add in the number 0, you get the whole numbers. When you add in 0. Maybe I use a different color for 0, just so that it doesn't look like another circle. So maybe I'll just write the word there. You add in 0. So the whole numbers are the natural numbers plus 0. So inside the whole numbers, you have the naturals and 0. And then when you add in negatives, you get the integers. And so that's throwing in negative numbers. So again, let me do that in a different color here. So the integers are all of the whole numbers plus the negative numbers, or you can think of it as the natural numbers, 0 and the negatives. So everything inside the circle for Z, the integers, is an integer. So that all whole numbers are integers, all natural numbers are integers. So if it's inside another circle, it is all of those things. Then when we throw in fractions and decimals, we get the rational numbers. So I'm going to use Q for that. So it's everything that we've talked about before, but now we've added in fractions and we've added in certain decimals, not all of them, some decimals. And so whole numbers are natural numbers, or I should say like the number 5. So my example here, it's a natural number, it's a whole number, it is an integer, and it is a rational number because 5 would be in the innermost circle here under the natural numbers. And then because that's inside these other categories, it's also one of these other categories. And then we've got stuff that is outside the rationals, which are irrational numbers. And so these are other decimals. And we've got most radicals, which is what we call square roots. And those are things that are irrational numbers. Which actually, I didn't mark this on the other slide. The irrational numbers, what symbol do they use? I'm not actually sure what symbol they are, so I'm gonna just write irrational. So these are divided into like 2 different groups because the irrational numbers do not interact with any of the other types of numbers. They're separate. So sometimes you'll see this as like a square part here, divided into 2 pieces. So a number is either rational or irrational. And if it's irrational, it's not any of those other categories. So that's kind of something divided into 2 pieces. And then that whole outside box are the real numbers. So essentially, real numbers are divided into 2 categories, rational, irrational. And then if you are rational, there are additional categories that you can fit into following this circle here. So this whole thing is what we call the set of numbers. And when you get to college algebra, you'll learn about things that are not real numbers, which is then yet another category. So now let's talk about different operations. And these are the things that you do to numbers. So we've got addition and subtraction. So addition is when you have a number, and then when you have plus another number, you're moving it to the right on the number line. It's getting bigger. And words that indicate addition are sum, total, plus. Subtraction is doing the same thing, but you're going to the left. So you're making it smaller. And then subtraction is defined as adding a negative. So if you're taking a number and you're adding a negative, that's the same as subtracting, and you're also moving to the left. Now, when you're subtracting a negative, when you go through what the definition means, you're basically, subtraction is adding a negative. Negative means opposite. So if you're subtracting a negative, you're taking the opposite of a negative, which is a positive number. So you actually are adding, and that makes you move to the right. So if you think of this is telling us we're taking the opposite of -3. And the concept that opposite of -3 is +3. So that's how it turns into a +3. So 2 negative signs cancel out because you're taking the opposite of an opposite, and they basically undo each other. The reciprocal of a number. So you can take the reciprocal of something, and that is basically flip-flopping it up and down. So you've got a numerator and a denominator with fractions, and that's just you're reversing what's on top and what's on bottom. If you've got a whole number, this creates a fraction over 1. So if I have 2, then the reciprocal is 1/2. And if you have a fraction with 1 on top, then the reciprocal, 1/3, is 3. So fractions, like if you have 2/3, the reciprocal is 3/2, but whole numbers, become fractions, and then certain fractions become whole numbers, and that's specifically if there is that 1 in the numerator. So multiplication and division, things we can do to numbers. So multiplication is when you're adding repeatedly. So 2 times 3 can mean that you're adding 2 3 times, but it can also mean you're adding 3 2 times. You get the same answer either way. You'll see the word product. Product is multiplication. And the numbers that you're multiplying together are called factors. So if you have 2 times 3, the product is 6, because that's sort of the result. And then, or you can say the product is 2 times 3. That thing written together is also known as a product. But the numbers that are actually involved there are called factors. So 2 and 3 are factors of 6 because they multiply to 6. Then division we have defined as multiplication. So you multiply by the reciprocal. So multiplication and division is basically multiplication. It's just multiplying by a specific thing. You have to take the reciprocal of the number first, and then you turn it into multiplication. So when you have negatives involved, because of the fact that a negative is flip-flopping across the number line, you're taking the opposite of an opposite and so on. This is related to multiplication and division. So an even number of negative signs results in a positive answer because they cancel out. Like when I had that, you're subtracting a negative, those cancel, they become a positive because you're taking the opposite of an opposite. If you have an odd number of negative signs, your answer is going to stay negative. So you just count how many negative signs you have when you're multiplying or dividing, and that tells you whether you're going to get a positive or negative answer. Absolute value. So absolute value is an action that you take. It is defined as the distance a number is from 0. So if I go back to where we were talking about opposites and negatives, we had -2 and 2. They're both 2 away from 0. So the absolute value would be 2 for both of those numbers. The absolute value of -2 is 2, and the absolute value of 2 is equal to 2 because they're the same distance away. Going back to my absolute value here. So because distance is always a positive number, basically that absolute value is going to make a number positive. If it's already positive, it stays positive. If it was negative, it becomes positive. And you saw what I wrote, I use these vertical lines. So I make them taller than my numbers to make it not get confused with the 1. So I make sure that it's taller than the numbers I'm writing, so it's not confusing. You have one on either side. And when you actually do the action of taking the absolute value, the symbols disappear. So when I actually make it positive, then I don't have those symbols anymore. And it's just the positive value 3. Exponents. So an exponent is a number that's slightly above and to the right of something. So that 3 is above and to the right, and it's smaller. This is called a superscript. An exponent is telling us that we're doing multiplication. And the number that's underneath that exponent is what's getting multiplied. And then the exponent tells you how many times that number is being multiplied. So 2 is getting multiplied 3 times. So 2 times 2 times 2. So the number underneath the exponent is called the base. The exponent can also be called power. That's the number that's above. And these are all factors. So I said under the multiplication slide that they're factors. So 2 to the 3rd power has 3 factors of 2. So 2 is showing up as a factor 3 times. If you have no exponent at all, you just assume that the exponent is 1, and that's really important. Okay, things involving 0. You get answers of undefined And one thing to note is undefined is not the same thing as infinity or zero. These are all different concepts. So different things. If you're dividing by zero, so you have zero after the division symbol, it's undefined. If you have a fraction and you have zero in the denominator, it's undefined because that's still dividing by zero. You get an answer of zero if you're multiplying by zero, and it doesn't matter where the zero is in the multiplication, it's still zero. Or if you have a fraction with zero on top, those give you zero. So it's really important to know the difference between these because it's a very important concept. Variables. So algebra is all about variables. We are looking at things where we have unknowns and looking at how they're related. So we call these unknowns variables because they can change or vary, hence the name of variables, because we can replace this unknown with a different number, and we can replace it with lots of different numbers. We use letters for our variables. So the most common ones that you'll see are like X, Y, and Z. You'll see A, B, and C to represent constants, and we'll get to constants on the next slide. Plural. X, Y, and Z are usually the ones that we're solving. So we're usually solving for one of those. A, B, and C if it's representing a number in front of something. When you get into higher levels math, you'll see Greek symbols for variables as well. So we've got mu, we have sigma. So these are Greek. And those are often used in higher levels of math. Those two particular symbols are used in statistics. So if you have to take a statistics class, you'll use those as your variables. There are tons of other Greek symbols that are used as well as variables. So I mentioned constants. So we use the word constant to represent a number because a number doesn't change. 2 is always 2. So anything that we do math with, like we multiply numbers together, all that stuff, which we call arithmetic, that is working with constants. So numbers are just also known as constants because they're constant in their value, opposite of a variable. Okay, so we're going to be doing things called solving, which involves equal signs, and there's things called equalities and inequalities. So equalities say that the things are equal. So we have what is used, the equal sign. So the left side has to equal the right side. So you don't use that symbol if that is not true. The sort of opposite of an equality is an inequality. So these are things that are not equal. So they could be less than, they could be less than or equal to. Could be greater than, they could be not equal. So these are other symbols. And so we've got the less than symbol, the less than or equal to symbol, the greater than symbol, the greater than or equal to symbol, and then the not equal to symbol. So those are all considered inequality, where in is sort of not equal. Expressions. So expressions are things that involve variables and constants, and we're doing operations on them. So we talked about our operations already. The exponents, doing multiplication, division, adding, subtracting. I'm going to put in square roots in there. Those are all operations. They're things we do to numbers. And so when you have the order of operations, that's the order that you do things. And so we do these two expressions. Expressions don't have the inequality or equality symbols. They're not complete. They're like phrases because they don't have these other symbols. They're just the numbers and the operations. Sometimes they have variables, so you can simplify them. We do two things. We simplify and we evaluate. Evaluate is something you do if you have only numbers. And it just means follow the order of operations and combine them to a single answer, a single number. Simplifying can also mean that same thing. So you'll see simplify used and it means evaluating, but it's also used if you have variables involved. And that means try to make things as small as possible or as few things as possible, but you may not always get one answer. You may get to a point where, excuse me, where you have things that are added together and you can't simplify it anymore. Okay, so terms, coefficients, and constants. We've already talked about some of these things. If you have an expression, and algebraic means it has variables. So 2x plus 5y minus 4x squared is an expression. It doesn't have an equal sign or other symbols like that. It's algebraic because it has variables in it. So each part is a term. So we can write this, if you have a subtraction, you rewrite it as adding a negative, going back to that definition of subtraction I talked about. And the terms are the things separated by the plus signs. So everything that I have circled, I probably should have circled it in a different color. Let's do that. So those are all terms. So there are 3 terms here. The numbers in front of the variable parts are called coefficients. So we have a coefficient of 2. Let me highlight the coefficients here. 5 and -4. Those are the numbers in front. And it is also a constant factor. It's a factor because these are actually multiplied together. 2x means 2 times x. So it's called a coefficient when it's specifically in front of the variable, but it's also a constant because it's a number, and it's a factor because they're multiplied. If you have something without variables, it's called a constant. So let's say I had this expression I added on plus 10. So 10 doesn't have a variable, so that is called a constant. It's still a term, and sometimes that's called a coefficient, and the coefficient is 10, but it's just kind of by itself. So I will also highlight that. If there is no number in front of the variable, we always assume that the coefficient is 1. So you can put a 1 there if there's not a number there, if it helps you. Like terms. So these are terms that are similar, and they're similar because they have the same exponents and the same variables. So, oops. Forgot I was in the highlighter. 2x and 5x are like terms. They both have x, and they both don't have a an exponent on that. But if you had 2x and 4x squared, these are not like terms, because one has an x, one has an x squared. So the exponents are not the same. And if you had 2x and let's say -3y, they are not like terms. They both don't have exponents, but they're different letters. So you have to have it match with the number with the letters and the exponents on those, and those are called like terms. If you have like terms, you can combine them by just doing the math on the numbers. So if I was adding 2x and 5x, I would just do 2 plus 5, and then the x hangs out. So you do the math on the numbers, and then the variable part hangs out. The solution is basically the answer to something. So it is the set of all values, and values is another way of saying numbers that make something true. So you could have multiple solutions. You could have multiple numbers that make something true. So that's why we say it's a set, because there could be many of them and they're grouped. So because it's a set of values to make a solution, it's also called the solution set. And that means that when you write your answers, you'll put them inside your braces. If you have something that has no numbers that make it work, there are no solutions. And a shortcut symbol for that is it's like an O with a slash through it. So don't use that to represent your zero, because it's a different symbol. So never put the slash through your zeros. You could have many values that make something true. You can also have all numbers that you put in make it true. And if any number makes it true, it's called, there are infinite solutions. And we say that the solution is all real numbers, or you'll just use that shortcut symbol for the real numbers, which is that R. So for about half the class, we're going to be focusing on linear equations. So it's an equation because it has that equal sign, and linear is a special type of equation. So it's written in the form AX plus B equals C. And A, B, and C are numbers. We usually use those to represent numbers, and then X's are unknown. So what makes it linear is that there's no exponent that you can see on anything. There kind of is one, but it's basically 1, and we don't write the 1. And so because the assumed exponent that we don't see is 1, because we don't write it, we call it a first degree equation, that first coming from the fact that if you had to put an exponent, it would just be a 1. So linear equations have no exponents on the variables. That is very specific. No exponents on the variables only. You could have exponents on the numbers, which is not on the variable. So now let's look at the various properties that allow us to do these, allow us to solve equations. So we've got the commutative property, which basically means you're exchanging things, commutation. And so that means you can rearrange the things that you can add, and you can rearrange the things that you multiply, because there's a property of addition and multiplication. This does not work for subtraction or division unless you rewrite those in terms of addition and multiplication based off of their definitions. Oh, excuse me. Associative property. So if you look at the word associate, one of the definitions is to unite or to connect, and we do this with parentheses. So we have a property of addition and multiplication. And so it's basically saying you can group things together that are added in different ways. Or if you have a whole bunch of stuff multiplied, you can group them in different ways. Again, this does not work for subtraction or division unless you rewrite them in terms of adding or multiplication. The identity property is something that says you can add or multiply and it will stay identical. So the identity property of addition allows us to add 0 and the thing stays the same. So 0 is called the additive identity. For multiplication, you can multiply by 1 and it stays the same. So 1 is the multiplicative identity. It keeps it identical. The inverse is to undo something or to do the opposite. So we have an inverse property of addition, which would be a number and it's negative, because those undo each other. Undo in the terms of, well, one, they're opposites, because we already talked about that, but they undo and they result to 0 when you add them. And so they give us the additive identity when you add these together. For multiplication, the inverse is also the reciprocal, We already defined reciprocal. It's the inverse the multiplicative inverse, because when you multiply them together, you get 1, which is the multiplicative identity. So these are related to the identity properties. The distributive property, or in long form, is distributive property of multiplication over addition. So if you look up distribute, it means give shares of something, deal out. You're sharing this thing to other things. So it basically means that if you have things multiplied together and inside the parentheses, you have more than one thing there, like added or subtracted, what's on the outside gets multiplied to everything inside the parentheses. It's shared among everything in the parentheses. So A times B plus C, we multiply A by the B and the C. We're sharing that A by multiplication for both of those items. And it works backwards as well. If it's in the back, it still gets shared among everything inside the parentheses there. So we have properties for equality as well that help us solve. So we have the addition and subtraction properties. And this basically is you can add or subtract a number on both sides of an equation, as long as it's the same thing. So whatever you do to the left, you have to also do to the right. And that's what keeps them equal. It's like you've got a scale, you're balancing things out. What's done on the left has to match what's done on the right for them to stay equal. And then we've got the multiplication and division properties of equality. So you can multiply or divide on both sides. You have to do the same thing in order for them to stay equal. So you can multiply both sides by the same number, or you can divide everything by the same number. But you have to do it to everything in order for it to remain equal. So this is basically, and once I add in the square root, all of the definitions and properties that we have looked at for weeks 1 and 2. So you'll have them all in one location. So that way you don't have to search your notes for everything. It's all in one place. And then hopefully watching this video, you can skip to certain properties that you need help on, and then you see a brief overview of it as I explain it. So hopefully this is helpful.